On this page, we're getting more detailed into something we had mentioned in passing in a previous page, that when trying to study a population, we choose a sample. It has to be a good sample. It can't be too large, I guess, because it's not realistic to use a large population or sample size, but not too small, and it has to be a good kind of random sampling. We're getting more detailed into that now. So the important point on this page is the goal here is to use a sample to make valid conclusions about a population. So the sample, the most important thing is that it be representative of the population. So if you were studying US adults, for example, like in that previous one about whether people support the death penalty or not, you wouldn't want to choose only adults, who watch this left-wing news channel or right-wing news channel. You don't want to only select Democrats or Republicans because you're skewing the results. Of course, they're going to go one way or the other more. And then age and all kinds of factors. You want to get a good random sample of different ages, different political backgrounds, all kinds of things. A representative sample is a subset of the population that reflects the characteristics of the population, kind of like we mentioned. Here we have a sampling plan. It describes exactly how we'll choose the sample. A sampling plan is biased if it is systematically favoring certain outcomes. Yeah, like I said, I think as humans, we even subconsciously, sometimes if we were to pick a sample, maybe we'll be unbiased, but a lot of times we'll be biased, just not even consciously thinking about it. But in our discussion of sampling plans, we'll focus on surveys. The next example is a famous one that illustrates how biased sampling in a survey leads to misleading conclusions about a population. So in this example, a magazine called Literary Digest sent a survey to 10 million Americans to determine how they would vote. More than 2 million people responded to the poll. 60% supported one candidate for president named Landon. The magazine published the findings and predicted that Landon would win the election. However, Roosevelt defeated Landon in one of the largest landslides in presidential elections ever. So how does that work? That 60% of the people that replied to that survey said they would vote for one candidate when, in actuality, the other candidate won by a landslide. It wasn't even close. So what happened there? The magazine used a biased sampling plan. They selected the sample using magazine subscriptions. Also, they used a sampling measured using lists of registered car owners and telephone directories. The sample was not representative of the American public. In the 30s, Democrats were much less likely to own a car or have a telephone. So they were really sampling more on the Republican side rather than the Democrat side. Probably not intentionally. They didn't probably just think of these confounding variables as coming into play. The sample therefore systematically underrepresented Democrats. The poll results did not represent the way people in the general population voted. Before we discuss another method for avoiding bias, let's look at some examples of common survey plans that produced unreliable, potential biased results. Those surveys, they're kind of tricky because especially if a news outlet or a magazine or certain websites want to do a survey, if they just survey the people that come to their website or read their magazine or subscribe to their news channel, then those people probably all, for the most part, think the same way. You're not getting a good sampling. So one way would be online polls. The American Family Association is a conservative Christian group that opposes same-sex marriage. In 2004, the AFA began a campaign in support of a constitutional amendment to define marriage as strictly between a man and a woman. The group posted a poll on its website asking AFA members to voice their opinion about same-sex marriage. But of course, you can probably guess what happened there. People that actually go to that website, of course, they are there because they think a certain way, right? People that are for same-sex marriage probably are not going to be going to this website very often. But it says almost 850,000 people responded to the poll. 60% favored legalizing same-sex marriage. Interesting. What happened? Against the wishes of the AFA, the link to the poll appeared in blogs, social networking sites, and a variety of email lists connected to gay, lesbian, bisexual groups. So they did this poll thinking, only the people that think the same way as us are going to be coming to this website and polling. But really, someone saw this poll and they sent it out, put it on blogs and everything, and said, everybody, reply to this poll so we can actually get a good representative of how people think, not just people that agree with them. The AFA claimed that gay right groups had skewed its poll. Of course, the results of the poll would have been skewed in the other direction had only AFA members been allowed to participate. Now, this is an example of a voluntary response sample. The people in a voluntary response sample are very self-selected, and they're not chosen. For this reason, a voluntary response sample is biased because only people with strong opinions make an effort to participate. Mall surveys. Have you ever noticed someone surveying people at a mall? So when you go out shopping, someone might ask you a few questions. They have a clipboard maybe. They're going to write it down. People shopping at a mall are more likely to be teenagers, younger, either very young or very old, retired people. They're not in the workforce like the kind of middle of the road typical Americans. In addition, unless interviewers are carefully trained, they tend to interview people with whom they are comfortable talking. For these reasons, mall surveys frequently overrepresent the opinion of white, middle class, or retired people. Mall surveys are an example of a convenience sample. So convenience samples are this is exactly how it sounds. It's convenient to poll people that are within close distance. They happen to be shopping at a mall, as opposed to going to find people that are in all different types of groups. So, example, how to eliminate bias in sampling. How do we do that? In a voluntary response sample, people choose whether to respond. In a convenience sample, the interviewer chooses those who will be part of the sample. They might not consciously realize they're choosing people in a certain demographic, but a lot of cases they are, like they mentioned with the mall. Collecting a random sample is like pulling names from a hat. So, you could literally pull names out of a hat. You write names on pieces of paper and pull them out, or a computer program can do it. In a simple random sample, everyone in the population has an equal chance of being chosen. Reputable polling firms use techniques that are more complicated than pulling names out of a hat. But either way, the goal is the same: eliminate bias by using random chance to decide who is in the sample. So random samples will eliminate bias, but even bias that may be hidden or unknown. The next three activities will reveal a bias that most of us have but don't know we have. We will see how random sampling avoids this bias. So when you're on this page, you should try this yourself. This is a little applet to see kind of how random samplings work. You'll see 60 circles. This is the population. Our goal is to estimate the average diameter of these circles by choosing a sample. So first thing you're supposed to do, just to kind of see how this is going to work, is choose a sample of 5 circles that look representative of the population of all 60 circles. Mark your 5 circles by clicking on each of them. They will turn orange. Record the average diameter of the 5 circles. Make sure that you have 5 orange circles before you record the average diameter. Okay, so let's see if we can do that. There's one. I'm just going to pick. So I'm seeing there's not a lot of large ones, so maybe I'll just pick one large one, maybe 2 medium ones. I'm just saying. And 2 very small ones. So there's my 5, I guess. I'm thinking that looks kind of average. And then they say that the average diameter there, excuse me, is 25.0. Okay, I'm going to. So when I choose the 5, when chosen, I had 25.0 is the average diameter. Okay, but I might be biased. I mean, in my mind, I'm thinking that that's a good representative sample, but maybe it's not. And you should try this for yourself. If you think maybe I chose too many big ones or too many small ones, you do whatever and think, or you can even just think randomly. I'm just gonna close my eyes and point and look and see which one I picked, that kind of thing. But now let's try estimating the average diameter of the 60 circles using random samples. So this little applet below, it's kind of awesome. It has these buttons you can click. The first thing we're going to do is click on Generate Sample button to get a random sample of 5 circles by clicking on the Random Sample button. The applet randomly chooses 5 circles. I'm going to record the average diameter for the random sample. Then we'll reset the applet using the Reset button and click on Generate Sample again to get another random sample. Let's repeat this 10 times and then record the average diameter for each sample. Okay, I'm going to see here. So I clicked on Generate Sample, and the average diameter is 12. But if you look at the orange circles, they're kind of the random sample. The computer generated it, so it must be random. They're mostly small circles, I guess. There's not even any medium ones in there. So that might be on the small side, maybe. Okay, I'm going to write that down. The average diameter the first time I clicked on Generate Sample was 12. Now let's keep trying it. We're supposed to do this 10 times just to kind of compare what they are. Okay, I realized that I can't keep all the writing on the page while I'm pressing these buttons, so sorry about that. I'll just keep it on my paper at home. Okay. So now I'll do the second one. Let's see. Generate random sample. That one looks a little more representative, I guess, of the larger circles. There's a medium one in there, but the average diameter on that one was 18, much higher than it was before. First time it was 12, second time it was 18. Let's try it again. I'm writing this down at home. And now the average diameter is 20. It looks like we're getting more of the medium-sized circles on this one. Okay. I press it a fourth time. The average diameter is 10, very small. The fifth time, I'm getting an average diameter of 16. So you can kind of see about where the average is going. These look like they're somewhere below 20 maybe. Close to 20, but not quite. This time the average diameter is 18 again. Let's do it again. 14. Okay, that was a lot lower. 22, the next one. We got 2 more times to get to 10. 16, and then 20. All right, so I've recorded all those. So I'll try it now. I'll calculate the average. We're adding all the values together that we found. We took all the average diameters that they calculated. The last ones were 18, 14, 22, 16, 20. I think those were the last 5 I wrote down. And then we also had the first 5 were 12, 18, 20, 10, and 16. Those were the 10 times I clicked on generate sample. Those were the values I got. Now to find the average, we'll take all those values, add them together. That's why there are plus signs in between, and then divide by the number of values there are. There are 10 of them because we pressed generate sample 10 times. So we'll do that calculation and see what the average. Okay, so when I add them all together, I got 166, and divide that by 10, you get 16.6. So when I chose my 5 circles above, before, not this generate random sample one, but when I chose my 5 circles, I must have skewed it. I had a bias. I thought I'm going to pick one big one and, 2 medium ones and stuff. But my average, the biased average, I guess you could call it, that I had was it 24, I think. Was that right? Yeah, so I wasn't even close. I think this is a lot more representative because the computer actually generated random groups or samples, and I didn't. I thought it was random in my head, so that just kind of shows human bias. We might not even realize it, but we're biased. I was biased because I like larger circles than smaller, I guess. I don't know why. I guess they stick out at you more, but obviously when you look at this picture, there are a lot more tiny circles than there are large circles. So it should be skewed more toward the small circles, if that makes sense.